Welcome user to the new chapter regression problems. In the last chapter we have completed types of unsupervised machine learning algorithms, and in the upcoming videos we are going to cover supervised machine learning algorithms. We have already discussed about the supervised machine learning algorithms in the introductory part of the machine learning. Now in this chapter we are going to see regression analysis. In the regression analysis we are going to cover simple linear regression, multiple linear regression, logistic regression, and some more rarely used algorithms includes support vector machine, decision tree, and random forest algorithms. So let's get started with simple linear regression. The first thing we do in linear regression, we use least squares to fit a baseline to the data. After that we calculate r squared, and at the end we calculate p-value for the r squared. There are lots of other things we consider while making regression model, but these are the three most important concepts behind the linear regression. Let us consider one example. The shown table shows salary of person with respect to age. Right here, age would be our independent feature and salary would be our dependent feature. So for this analysis, we will make regression model that will predict salary with respect to age of the person. But how we can get that prediction? We all are familiar with equation of line. If we can find out best fitted line for this dataset, we are able to predict exact value of prediction. For simplicity, I have mapped above data into two-dimensional space. Now our task is to find out best fitted line that will shows minimum loss function. Let us consider one random line. Now calculate distance between each data point and line. Square the distance and add all distance. Calculated distance is called as a sum of residual. Now rotate the line and calculate sum of residual for this condition. Repeat the steps and calculate sum of residual for different rotations. Now draw a graph has sum of squared residuals on y-axis and different line rotations on x-axis. Now find out the line which has the least sum of squared residuals. So in this case, the noted line rotation has the minimum sum of squared residuals. In reality, gradient descent algorithm will help us to find out the minimum point of the function. And finally, we can conclude for this dataset, this is our least square rotation. Sum of squared residual is also called as the cost function or loss function. Now if we see equation of this line, y predicted line has the two values. First is intercept and second is slope. If we will get best value of m and c, we will get best fitted line, where m is the slope and c is the intercept. The y predicted equation represents how independent variable is related to the dependent variable and error in the regression model. Right here you can see standard equation of simple regression model, where b0 and b1 are the parameters of the model and e would be the error. Mathematically we can calculate value of b0 and b1 by using mentioned formulas. Now consider the dataset that we have discussed already. For this dataset, suppose we have found out value of b0 and b1. Now we can say our model is ready and we can predict new entries. Suppose anyone want prediction of the age 23, we are just going to replace x value in the equation of prediction, and we are able to predict salary for the age 23. This is how simple linear regression would be carried out. In the lesson number 17, we have seen general approach of the regression analysis, and we have noted that before going to apply any machine learning algorithm, we split data into training and testing set. There are so many splitting methods we can use, but we are going to discuss three important methods that we use all time. Right here you can see three methods that we use to split data. The first is hold out cross validation technique. The second is leave one out cross validation, and third is k-fold cross validation. Let us discuss each method one by one. Hold out cross validation method is very simple method. In this method we divide data into training and testing set. Over here you can see we have divided data into two parts. Training set we will use to create model and testing set we will use to validate trained model. The percentage of splitting is dependent on the user requirement. But do remember, training set would not be less than 50% of the total data. But splitting would be done randomly and there would not be any overlapping of the observations. The second method is leave one out method. As the name suggests, we select randomly one observations for the validation. Once model is developed, we find out the error. We will repeat the steps. Each time we select only one dataset for testing and remaining dataset for training. We do this for all the data points and finally we take average of all the errors to get final error. Right here you can see structure of leave one out method for the small dataset. K-fold validation method is effective and it uses combination of hold out method and leave one out method. Let us discuss with the help of one simple dataset. Suppose we have dataset contain 100 observations. So if I choose k is equal to 5, then whole dataset is grouped into 5 subsets. Each group will contain 20 observations. So 4 groups we will use to create model, and the remaining group we will use to validate. We will compute the error and we will repeat the steps, and finally we will take average of the all errors. The average error will represent total error of the model. This is all about the validation techniques. The accuracy that we calculate will be represented by r squared or adjusted r squared. The information about the r squared and p-value we are going to discuss in the next video. This is all about the simple linear regression. In the next video we will see how we can implement linear regression in the MATLAB. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our feature. Happy MATLABing.